Kia ora koutou, welcome to this video, NCEA Science 1.1 on forces. Today we're going to be looking at, indeed, forces. So we'll go over that. So what is, first of all, a force? A force is a push or a pull on something. Push or a pull on an object. So quite simple, just pushing or pulling an object is a force. And there's lots of different things that can apply a force. Forces are measured in newtons, and we'll get into the relevance of that later, but forces are measured in newtons. And the symbol for newtons is a capital N. So if we've got this box here filled with stuff, we will just have a look at what some of the forces might be that are acting on this box. So to begin with, we have the weight force. So the weight force, which is as a result of gravity, will be pulling the box down. So we show forces with an arrow like that. The size of the arrow indicates the size of the force. So we need to make sure that these arrows are approximately comparable to the other arrows that we would show describing the forces on the box. So this force, we'll call it, this is the weight force. And are there any other forces that would be acting on a box if it was just sitting on the ground? What do you think? Well, yes, there does have to be another force, and we'll look into what would be happening if there was just this one force acting on the box, but it would not be remaining stationary on the ground. So what we need is a force that will support the box when it is on the ground, otherwise it would just accelerate downwards. So there is, as a result of the box resting on the ground, there is the support force, which if the box is stationary will be of the same size as the weight force that is acting on it. So we've got the support force. Okay, so what if, those are the only two forces that we would have acting on the box if it was just resting on the ground. What if somebody came along and started pushing this box towards their room? So if somebody was from this side pushing that box, what would the force be? So we would have a force if they were pushing from left to right. We always show the arrows, coming out from the box like this. So there would be, this would be the push force. So there is a push force if somebody is pushing the box. If there is actually a push on the box, there would be a push force. And once the box started moving, we would begin to see another force, which would be the friction force. So the friction would be, and while the push force is happening, it'll most likely be less than the push force, but we'll go into that later. So you'll have this friction force going in the opposite direction to the push force. So these are the only forces that we will need to know about for this topic. We will only ever look at objects in a two-dimensional view with a push force, friction force, weight force, and support force all being directly opposite to each other. What we will look at now is how we would calculate the overall force on an object, or the net force on an object. So let's say the box is on the ground, and we measure forces in newtons, remember that, so we're going to put a value on each of these forces. So the weight force, let's say that is 100 newtons. The weight force is 100 newtons in the downwards direction. Let's say the support force is 100 newtons as well. So the weight force and the support force are 100 newtons. To calculate the net force on this object at this stage, we would subtract these forces from each other. So you'd just take the largest value and subtract the smaller value from it. So in this case, they're both the same value. So 100 minus 100, without saying what the size of the force of the push force and the friction force is, these forces are balanced. So the net force, 100 minus 100, the net force at this stage is 0. We'll add in some more values for these forces. So let's say the push force is 50 newtons. So the push force is 50 newtons, and we'll give the friction force a value, let's say it's 20 newtons. So what would be the net force on this object now then? So the friction force, and to show that this is 20 newtons, this should be smaller than this arrow. It might be marginally, but I probably haven't drawn it as well as I should. So that's something to keep in mind if you're showing the forces on an object and you want to show that one force is less than the other. So this arrow should be smaller than this arrow. What is the net force on this box now? We've got 50 newtons in that direction and 20 newtons in that direction. So we take the larger number, 50 newtons, and minus the smaller number from it, and that equals 30 newtons. So the net force is 30 newtons in the right direction. So when we're talking about the net force, we need to say which direction the net force is. So for this object, the overall force is 30 newtons to the right. 30 newtons. So because there is a net force on this object, the way we describe the forces acting on this object is that there are unbalanced forces acting on this object. So if the net force was 0, it would be balanced forces acting on the object, but if there is a net force, then we call that unbalanced forces. We're now going to look at the impact or the effect that unbalanced forces have on an object, or even the effect that balanced forces have on an object as well. So have a think. What do you think would be happening to this box if there is a net force of 30 newtons acting on the object? Is it going to be? You can use some of the vocabulary that we've used in the previous lessons. So will it be moving at a constant speed? Will it be accelerating? Or will it be stationary? Which one of these things do you think this box will be doing when there is a net force on it? So to investigate unbalanced and balanced forces, we're going to do another PhET. Well, we haven't done a PhET activity yet, but there is this forces in motion PhET activity. So you can go onto Google, PhET forces and motions basic, motion basics, and you'll find it there. We'll click on this first link, and then just click play. That should just load for us. Perfect, and we'll go straight into motion. Okay, so we have this box on a skateboard, and this skateboard is works with no friction at all. So we're assuming that there is no friction force on this skateboard. So what we're going to do is we've got this person there, and they're kindly going to push the box for us. We're going to click this so that we see the speed. We've got speed meters per second there. Perfect. We are just going to apply a force. So there's 1 Newton of force being applied. In fact, let's make it 10 so we get a little bit more. So have a look at what's going on with the speed here. So we're applying 10 newtons of force, and the speed is increasing. How long do we think it's going to increase for? Will it increase until it gets to a certain speed, or what? What do we think is going to happen? We'll just keep watching. I might pause the video, and then we'll wait until we get to the end. So the speed is still increasing. We're still going at 10, we're still applying 10 newtons of force. But look at this, the speed is still increasing. So we would say that this box is accelerating. So what does that mean? What answer did you give for the box here? Did you say it was going to be moving or accelerating? I imagine that you would have chosen one of these two, either constant speed or accelerating. But we can see that it's not until, so the man has just let go of the box, it's not until there are no forces acting on this box that it actually moves at a constant speed. So with unbalanced forces, if there is an unbalanced force acting on an object, the object will accelerate. So we'll write that here. So unbalanced forces acting on an object means that the object will be accelerating. So in that case, what is happening if there are balanced forces on an object? So balanced forces, if there was no net force, if that showed zero, if there was 0 newtons on this box, perhaps I would assume that you might say that the box would then, in that case, be stationary. But if we look back at our box on a skateboard here, which is still moving because there's nothing to slow it down because there's no friction in this simulation. There are no forces acting on this box, or no left or right forces. So how would we describe the motion of this box here when there are no forces? It's not stationary, is it? It's still moving at 40 meters per second. So if there's a balanced force on an object, it will be either moving at a constant speed or it will be stationary. So a net force on an object means that it is accelerating. A balanced force indicates that it is at a constant speed or stationary. So we'll write that down. Balanced force object be moving at a constant speed or stationary. So it depends on whether, if the object was already moving and then there was and then the forces became balanced, then it will continue moving at a constant speed. If once a force acts upon it, then it will accelerate. So the acceleration could be, that's a general term that we use for deceleration as well. So if I now recruit that man again, that will kindly pop back up for us, if I recruit him to then start pushing in the opposite direction, so we'll get the man to push from right to left, what do we think is going to start happening then? We'll have a look. With 10 newtons of force, look at this. So the net force is 10 newtons to the left, and the box is still moving to the right, isn't it? It's still moving in this direction. So the net force does not tell us the direction that the object is going to be moving in, but we can see that it is accelerating in this direction, or it is decelerating. So the net force indicates that an object will be accelerating in that direction. It doesn't actually tell us if the object is moving in that direction already. We need to know more information about the object. So that is all that we're going to cover for this video. So we've talked about forces, we've talked about balanced and unbalanced forces, and then we can see here what balanced and unbalanced forces, what effect they have on the object. So unbalanced forces will accelerate an object, a balanced force will mean that an object is moving at a constant speed or it is stationary. Okay, and we will leave you there with this video, and we'll let this man keep slowing this box down until he will then speed it up the other way. Thanks for watching the video. I hope you enjoyed. Keep like and subscribe for more science videos. I'll see you next time. Thanks.